Many of you wanted the ray diagram when the object is placed at C. So I have drawn the concave mirror, center of curvature, focus, pole, kept the object at C. This is AB. One ray is taken parallel to principal axis. It gets reflected passing through the focus. Another ray is taken passing through the focus. It gets reflected parallel to principal axis. Both these rays get intersected here. So the image is formed over here. You can see the object and the image, both of them are one below the other. So what we get is when the object is placed at C, we get an image. Okay, at C itself, it is real, inverted, same size of the object formed at C. Okay, so I will write that. When the object is at C, the image is formed at C. It is real, okay, inverted and same size as that of the object. Okay, so this is about the ray diagram of a concave mirror when the object is placed at C. Now we will see about the convex mirrors. We know what are convex mirrors, and convex mirrors are those mirrors, okay, which are bulged outwards. I'll draw one convex mirror, and for convex mirror we have only two ray diagrams. Okay, the first one is when the object is placed at infinity, and the second one is when the object is placed between infinity and pole of the mirror. Only two ray diagrams. So I will draw one ray diagram when the object is at infinity. I have drawn one convex mirror, okay, which is bulged outwards with center of curvature 4 centimeters, with radius of curvature 4 centimeters. This is center of curvature, focus and pole. Now we will keep one object at infinity. When the object is kept at infinity, what you do is you draw the object half above the principal axis and half below the principal axis. This is because when the object is at infinity, the rays of light will be coming parallel, or we draw them parallel to principal axis. Okay, so I'll draw one ray parallel to principal axis from B, as well as one more ray parallel to principal axis from A. Okay, so I have drawn the rays parallel to principal axis from A as well as B. Okay, now what happens is, this convex mirror is a diverging mirror. The rays of light will get reflected from the focus. They start from the focus like this, okay, like this, and they get reflected away from the principal axis like this. Here also, down also same thing. You can watch it carefully. So from focus, draw one dotted line and produce it this side. So these are the two reflected rays, and these two reflected rays are originating from focus. So you can see this side they never meet in front of the mirror, but behind the mirror they are meeting at the focus. So the object is formed at F. It is point sized, okay, and it is virtual. Okay, so I will write it. The image is formed at F. It is point sized, it is virtual. So the image is formed at F. It is point sized and virtual. Virtual images are formed behind the mirror. Real images are formed in front of the mirror. Okay, so this is about the ray diagram of a convex mirror when the object is at infinity. So I will write it here. Okay, object at infinity. So it is object at infinity. Now I will draw another ray diagram when the object is between infinity and pole of the mirror. So we will draw the ray diagram when the object is between infinity and pole of the mirror. Now I have drawn a convex mirror of radius of curvature 4 centimeters. This is the center of curvature, this is the pole, drawn the principal axis, and you all know the focus is the midpoint of P and C. So I will mark it as at 2 centimeters. Okay. So I will keep one object anywhere, you can place it anywhere above the principal axis. So I will draw one object at principal axis. On the principal axis, above the principal axis, not half below and half above the principal axis, as it was drawn when the object was at infinity. Okay, so I will take one ray of light parallel to principal axis. The ray of light parallel to principal axis will get reflected diverging from the focus. So from the focus it will get diverged. Okay. It will get diverged from the focus. Now another ray of light you have to take, okay, passing through the center of curvature, and the ray of light which is passing through the center of curvature will get reflected back along the same line. Okay, and this ray will produce it behind here. This ray of light we have taken passing through the center of curvature, and the ray of light passing through the center of curvature will get reflected back along the same line. So you can see these two reflected rays will not meet this side, but they have met when we have produced them behind the mirror. So the image will be formed here, that is A dash B dash. This is virtual, erect and diminished. Okay, so the image is virtual, erect and diminished. Okay, virtual, erect and diminished means smaller than the object. Okay, this is about the ray diagram of a convex mirror when the object is placed between infinity and pole of the mirror. Okay, so now we will see uses of convex mirrors. So uses of convex mirrors used in street lights to scatter light to a larger area. Okay, used in street lights to scatter light to a larger area. Second is used in rear view mirrors of vehicles to see the objects coming from behind, and it is used because it gives an erect image and a wider field of view. This is the reason why convex mirrors are used in rear view mirrors of vehicles, and it is also used in the the shopping malls. Okay, used in shopping malls also, shopping malls and parking areas, okay, to get a wider field of view. Okay, these are the uses of convex mirrors. Now we will see some points to remember while drawing the ray diagrams. First thing is the ray of light parallel to principal axis will get reflected passing through the focus. The ray of light parallel to principal axis will get reflected passing through the focus. Second is the ray of light passing through the focus will get reflected parallel to principal axis. And the third one is the ray of light passing through the center of curvature will get reflected back along the same line. Now these are few points to remember when you draw the ray diagrams. Okay. Now next we will see the refraction of light, and that we will do in the next class. What is refraction? What is the main cause of refraction? Okay, what is all that? We'll see in the next class. Take down these notes till then. Okay, bye till then. Okay.